Alright, let's solve this equation. Notice this is an exponential function is now equal to another exponential function, but the bases are very different. There's a base 3 and a base 5. And the way we're going to approach this problem is actually use a logarithmic function. So let's balance both sides by the log function. And when you balance both sides, we end up seeing something like that. Now we use log properties. And now it looks like a linear equation. So we're going to collect like terms, try to get x on one side. And let's have a common factor of x. And now we could divide both sides of an equation as long as it's not 0. And in this case, we're not dividing by 0. We could use log properties to simplify this a little bit. Sometimes it's very hard to know when to stop. So usually in mathematics, we try to simplify, which means make the expression look smaller. So that looks pretty small. This is what we call an exact answer. And if you put this in a calculator, you'll get that x is equal to negative 0.7861766, and it just keeps on going. Let's approximate this to the nearest thousandth. So x is really approximately negative 0.786. And the reason why it's a 6 is because we're rounding down. 1 is less than 5, so we will round down to the nearest thousandths. Well, there you go. We can solve an exponential function equal to another exponential function using logarithmic functions to balance the equation.